Lilliana, and I'm from Nanjing Tech University of China. Um, Today, I would like to share with you some preliminary findings of our research on the thermal effects of urban parks. And my presentation contains four parts. And first, I'd like to introduce a little bit about the research background and questions. So this is the city where we did the research, Nanjing. It is located in the southeastern part of China with a humid subtropical climate. So what's special about the city? It is known as one of the four furnaces in China, which means it has really hot summers, and the air temperature can reach 41 degrees Celsius in the summer. And also the winter here is cold, and the temperature can be as low as minus 13 degrees Celsius. Another feature about the city is that it has been awarded as a national garden city in China because of its high coverage rate of urban green spaces and especially urban forests. It has about 200 public parks, and the park area per capita is about 16 square meters. So we are really interested in exploring questions like how and to what extent can urban parks affect local climate, both temporally and spatially, and what are the key factors determining the magnitude of park thermal effect. Particularly, we are interested in studying the temporal pattern and weather factors of the thermal effect. The reason for this is because of what I just mentioned, the climate characteristics of the city, hot summer, cold winter, and the wide range of annual temperature. So this study provides us a good chance to examine the park's thermal effects under various weather scenarios. Besides summer cooling, we also want to know if the parks can regulate the harsh winter climate. So we have established this monitoring network to measure the air temperature both in the parks and in the building areas. We selected seven representative parks for field measurement, including two large urban forests, three small woody fields, one artificial park, and one waterfront park. We also selected two reference sites. The urban reference site is at the center of the city with a compact high-rise morphology, and the suburban reference site is at the outskirts with scattered low-rise buildings surrounded by large areas of greenland. So these two reference sites represent two extreme development mode. The one is densely built up, and the other can be considered as non-developed. The table shows that the seven parks have totally different size, shape, altitude, vegetation, and land cover characteristics. The sensors were placed at both the center and the border of each park and at spots with different land cover types. We also set several transects radiating from the park boundary to outside areas for both fixed and mobile measurements to see how far the urban parks can affect the climate of nearby building areas. So here are some of the instruments we used in the study. The field measurement lasted from September 2021 to August 2022. So we have a whole year data for analysis. It is noteworthy that the year of 2022 witnessed an extremely hot summer when the maximum air temperature was observed to be 14 degrees Celsius. And there are 39 days have daily maximum air temperature above 35 degrees Celsius. So overall, we have done 5 parts of data analysis, and I will introduce one by one. First is the overall temporal pattern of Park thermal effect. Here, thermal effect is indicated by delta T, which is the temperature difference between the parks and the reference size. We calculate the delta T for each hour across the year and present the result on this diagram. Here you can see the x-axis means each day of the year, and the y-axis each hour of the day. We use blue colors to denote the cooling effect, and yellow-red colors to denote the warming effect. Here are the results. When compared with the urban reference site, the parks display 3 distinct patterns of thermal effects. Pattern 1 is characterized by a constant cooling effect across the year. The 2 large urban forests belong to this pattern. And pattern 2 is characterized by a daytime warming and nighttime cooling effect across the year. The waterfront park and artificial park belong to this pattern. And pattern 3 is a little bit more complicated. It's about day-long cooling effect in summer and daytime warming and nighttime cooling effects in other seasons. And the small woody fields show this pattern. So what we learn from the results, this pattern 3. But we compared with the suburban reference site, the urban parks are more likely to display a cooling effect in the daytime and warming effect in nighttime. So what we learned from the result is that the selection of the reference site is a key issue when we study the thermal effects of urban green spaces, because the delta T depends not only on the temperature of the park, but also on the temperature of the reference site. So changing the reference site may make a huge difference to the result. Here is the occurrence. These 2 pictures shows the occurrence frequency of cooling warming effects. In summer, we can say that all parks displayed a dominant cooling effect, which is definitely a significant benefit for mitigating the excessive summer heat. The 2 exceptions are the artificial park and the waterfront park. They display no effect or even warming effect during summer daytime, probably due to the large areas of impervious surface and water areas. In winter, 4 parks show occasional warming effect, which is certainly a desirable effect. However, all parks show high frequency of cooling effect. This may exacerbate the already cold and uncomfort winter climate. So we accumulated the hourly intensity of cooling warming effects over the entire summer and the entire winter, and we found that the cooling effect has much stronger accumulative intensity than the warming effect. And the 2 large urban forests always show the greatest cooling intensity than other parks among the 7 parks. We also calculate the winter heating degree days and summer cooling degree days to analyze the impact of parks on building energy demands. And the HDD and CDD are defined as the number of days with daily average temperature below or above the air conditioning temperature. And we found that the parks, compared with the urban center, the parks can reduce the summer energy demand by about 9% to 67%. And again, the large urban parks can reduce the greatest decrease in the cooling demand, and the parks can also increase the winter energy demand by 4% to 80%. So we also conducted a multivariable linear regression analysis to identify the key weather factors of park thermal effects. And based on these regression models, we were able to establish the quantitative relationship between thermal effects and background key weather factors. And we believe that this may help predict the park's thermal effects under future climate change scenarios. So here are the conclusion. For a city with hot summer and cold winter, the urban parks have both positive and negative effects, and the urban heat island effects are not always a bad thing. For it may help cut the winter heating energy demand. And what we learned from the study is that we should put special emphasis on large urban forests because it always provides the greatest cooling benefits. And as for the design of new parks, the appropriate land cover arrangement and selection of tree species always remain the key issue to ensure desirable summer cooling effect and winter warming effect. Our future research will focus on the spatial pattern and underlying factors. Especially, we will explore the cooling distance of urban parks. Actually, we have done several mobile measurements along the transects, and we were fascinated by the result that the cool air can transport several hundreds from the park to nearby areas, and hopefully we could identify the urban design factors for the cooling distance. Thank you very much. Sorry, I have run out of time.
We've got time for questions. I've got a question at the back there.
I don't need the microphone.
Oh, you don't? You're not wrong.
Thank you for the wonderful presentation. I was just wondering, at the different sites, have you made any measurements of sky view factor or looked at how sky view factor might,
Yes, we do measure the sky view factors of each measuring point and the LAI of each point. So we are able to see how these factors change with the time, with different seasons.
And so with a very built-up urban site in the city centre and the forested sites, do they have similar sky view factors, but one because of trees and the other because of buildings, or is the forest site the one with the most coverage?
Yes. The parks, for these densely built up areas, we are surprising to see that they displayed a weak cooling effect in the daytime because of the self-shading of the buildings, the high-rise buildings. But this shading effect may not change with time. But for the urban parks, when the winter comes and the autumn comes, the leaves may fall and the SVA factors may change. So that's the difference.
Okay. Thanks a lot, Lillian.
Thank you.
Our next speaker is Sebastian Fersch from Western Sydney.